Okay, so this is how you do number 14 on the chapter 13 homework. So the problem asked, the underlying question of the problem is how far from the sun will Halley's Comet travel before it starts to return from its journey? And looking at the diagram, we're looking for this value of x. Basically, this is the sun, this is the comet, and how far from this tip. So I'm gonna start off this problem by writing some important conversions. So one astronomical unit is 1.5 times 10 to the 11th meter. And then the period of the comet is 75.6 years. So to solve this, I use Kepler's equation of the square of the period. So, and in that I isolated r cubed to solve for r. So in this solution, I didn't include the specific variables, but once you plug in the gravitational constant, the mass of the sun, convert the period to seconds, so that's 75.6 times 365 times 24 times 60 times 60, and you square that value, you get t squared, and then divided by 4 pi squared, and you take the cube root of the whole thing, or the 1/3 power of the whole thing, and you get r is 2.67 times 10 to the 12 meter. And then you have to remember that this specific Kepler equation relies on the idea that r is the semi-major axis radius. So r is basically this part of an ellipse. So in this case, r equals a. So going back to our original diagram, this whole thing is 2a. So because r equals a, this whole thing is also 2r. So 2r minus x plus 0.57 AU. So 0.57 AU plus x equals 2r, or that's basically the horizontal distance of the whole ellipse. And then you set them equal to each other and you isolate the variable x. You plug in r from your first answer, and you convert this AU to meters, which we can get from here. 1 AU equals 1.5 times 10 to 11 meters. And once you do that, you should get a value of approximately 5.26 times 10 to the 12 meters. Yeah. So that's how you do problem number 14 on chapter 13 homework.